Hello guys, today we are going to look into problems related to tree traversals. Let's look into all the tree traversals one by one. Before we look into tree traversals, we should know, given a problem, how do you represent a tree. Usually in lead code or any places, you would be given the representation of a tree, but you should also know how do you represent a tree very quickly in within a few seconds. Okay, so a tree node contains a value. Usually in an interview you can easily represent a tree with an integer, but otherwise unless it's a try or something, you just assume and code and assume and put the value as an integer. And the tree contains left and right. Here if you see, a tree contains value and a tree contains left and right, and it's good to have a constructor which takes in the value and sets the value of that current node. So I have a class called tree node. I have three properties. One is the value, which is the data, and the children left and right. This is how you represent a binary tree. So I just generically said tree, but it's a binary tree. If it is a tree which contains, it's not a binary tree which may contain more than uh, two nodes, then you should end up in doing something like this: list of tree nodes or children. So if you have been given a problem and the interviewer said that you will not be given a binary tree, but you might need to traverse. So you should have it like this. But that we will look into that problem in a different day. I think this. So Inorder traversal, whenever you are given a tree and say that you need to traverse in order, the Inorder traversal traverses the tree like this. It goes to the left and then root and then right. So first it goes to the left node and it prints the root and it prints the right. So Inorder traversal will result in printing the tree in sorted order. If it's a binary search tree, if we do a Inorder traversal of the binary search tree, it will result in the sorted order. Suppose that you are given an array which is sorted. You are given a tree which is sorted and you need to go to the kth element. You can keep traversing the array and have a counter, and then when it reaches the counter equal to k, you can print it. So Inorder traversal can be used to solve such kind of problem. And even this Inorder traversal can be used to solve another tricky problem. If you are given a binary, if you are given a binary tree, to check whether the tree is a binary search tree or not, what you can do is do an Inorder traversal of the tree and check if the previous element is less than less than the current element. So if to check a given tree is a binary search tree or not, do a Inorder traversal and find out whether the current element that you are doing is less than the previous element, is greater than the previous element. So that way we will be able to find out whether the binary tree is binary search tree or not. So let's, with that being said, let's look into this code. What I'm using recursion to solve this problem. You are given a tree which is root node of the tree. I will return uh, the array list when the root is null. I'm just returning it. Else what I will do is I will do an in-order traversal of the root dot left, and then I will add this current value to the array list, and then I do a in-order traversal of root dot right. What will happen is it goes to the root dot left and root dot left. So if given a tree, it keeps traversing to the root dot left, leftmost node of the tree, which would be the smallest element in the tree. For example, if you are given a tree, you need to find the smallest element in the tree. What you need to do is you need to go to the leftmost node of the binary search tree. So that way, what it does is in our traversal, it goes to the leftmost node of the tree and then adds that node, and then it adds the root node, and then it adds the right node. The left root right. So finally you will get a array with print the tree in another traversal. I'm just running this solution. Let's see. Yeah, the tree is like this. Um, 2, 1, 3, and 4 was the tree. Root node is 2, left node is 1, right node is 4, and right node's left node is 3. So we are able to print the tree binary search tree, and it is in sorted order. I think I have explained you how in-order traversal works, and I also have explained you in what scenarios in-order trees will be useful. So just that I have mentioned those scenarios, but we will take up those problems in a different video. Thanks for your time.